This lesson is about simplifying rational expressions, and you'll see this in a little bit when we get to some of the future pieces of this lesson. But to be able to simplify rational expressions, we do need to be able to factor. And I know it's been a while, it's been like a hot minute since we've done some real factoring. And so we're going to start the lesson with a review of factoring. So just to recall a couple of things, factors are things that are multiplied. Okay. So factors are things that are multiplied to give us something called a product. And so if you look at a rectangle, okay, and the height of the rectangle is 3 and the width of the rectangle is 5, and you were asked to find the area would be the base times the height, or length times width, whatever words you want to use there. And in this, the 3 and the 5 are factors, and the area, that's really messy. Try that again. The area is the product. Okay, so we have the product and then we have the factors. So in theory, if you were given the area, you would be able to find the factors, like what multiplied to give me this particular area. Now with numbers, there are often more than one pair of factors, but with polynomials, there's usually just like one pair of two factors, of factors that we can find. So when we're factoring using the area model, we are given the area and we're going to be looking for the base and the height, or the length and the width. So in your lesson, there are 5 factoring problems, and I think some of them are set up for you. I pulled them from some different pieces of the work that we've done before, but we'll start with x squared plus 8x plus 7. And we set up our area model. And when we presented this in class months ago, we did a lot of multiplication problems. And so we know that, and I'm just going to use a different color here for a second. We have something with an x here, something with an x there, something that's not an x, it's a number, and something that's not an x, it's a number. So when we multiply them, we always end up with the x squared term in the upper left. We always end up with a numerical value in the lower right. And then in the two other corners, the upper right and the lower left, we have some number times x, okay? And that's how it always works when you're multiplying binomials, okay? So it always comes out that way. And if you do enough multiplication problems, it becomes very intuitive, which is why we practice. Even when you understand the math, you do a lot of practice problems because it helps it stick in your head. Now, in this particular problem, we know the x squared goes here, and we know the 7 is going to go here. These two have to add up to give me the 8x, because the x squared is always in the upper left and the constant's always in the lower right, and then the two other diagonals have to add up to the 8x. And what we're looking for here are two numbers that when we place them, we're going to place them right there and right there, they are going to multiply to give us a 7. So when we multiply the base and the height, these two numbers are going to give us 7, but when we add them up, they're going to be able to give us an 8. Okay, and that's part of that process of reasoning your way through a factoring problem. So we've got the 7. Now, the reason we start with the 7 and not with the 8, there are an infinite number of things that add up to 8. Okay, like there's 4 plus 4 and 3 plus 5, 2 plus 6, but then don't forget negatives. You could have like -1 plus 9, okay? Infinite number of things, and we do not want to have to pick from an infinite number of things. However, if we're dealing in integers, there's just a finite number of things that can multiply to give us 7, and we like finite way better than infinite when it comes to evaluating possibilities. So to get a 7, we could do 1 times 7. Now you could also do -1 times -7. But typically when I'm factoring, I don't pay a whole lot of mind to the signs, because when you're thinking about what do they have to add up to, the signs usually come out in the wash. So they need to multiply to +7 and add up to +8. Well, that would be this pair. If I have +1 plus +7, sorry about the double plus signs there, that would give me the 8. And what that tells me is that in my boxes, I have 1x and 7x. So I'm going to pause here for a minute. I'm going to erase that catastrophe and just allow you to see how that works. So we have x squared. Here's the 8x when you're adding up that area. 1x plus 7x would give you 8x, and here's the 7. And if you add all 4 of those up, you're going to get this. This is our area, and what we want are the factors. This is the easiest kind of factor because the x squared only factors one way. The only way to get x squared is to do x times x. And then from here, we just reason it out with multiplication. X times what gives me 1x? Well, that would be a 1. And x times what would give me 7x? And then you can always use that last box for checking. So if you factored it correctly, every single one of these should check. X times x is x squared, x times 1 is 1x, 7x, and 7. And so my factors would be x plus 7 and x plus 1. Next problem. Next problem is, I gotta look at my sheet because I did write them all down, x squared minus 6x plus 8. And so we set up our area model. We know that the x squared goes in the upper left and the +8 goes in the lower right. And then the tricky part is figuring out what are the numbers that go in the other 2 spots. So we're going to start with the factors of 8. Well, I have 1 times 8 and 2 times 4, and that's all I've got. If I want them to add up to 6, well, 1 plus 8 would give me 9. If I make one of them negative, I'll either get 7 or -7. So if I subtract them, I get a 7. That's still not what I want. If I do 2 plus 4, I'll get +6. But if I want a -6, I could use -2 and -4. I could make them both negative, and that will work. -2 times -4 gives me +8, and -2 plus -4 is -6. So here we'll have -2x and -4x. It does not matter which of those 2 boxes you put them in. Okay, so I put the -2 in the upper right, but you could have put the -4 there. And now we do our factoring. So x times x gives me x squared. X times -2 gives me -2x, and this will be the -4. And when I multiply -4 and -2, I get the +8. So my factors are x minus 4 and x minus 2. That is the answer. So make sure when you're filling this in on your page that or on formative that you are getting the factors. Next one is 3x squared minus 8x plus 4. Okay, now math is consistent. So we're going to have 3x squared and we're going to have a 4. And here's where it's different. If you try to factor the 4 and try to find factors of 4 that add up to -8, not going to be able to find it because they don't exist. So what you need to do is you need to take the a value times the c value and get 12, and 12 is the number that we are going to factor instead. And so we'll have 1 times 12, 2 times 6, 3 times 4, and that's it. So of these pairs, which one of those pairs can give me an 8? Well, I can't get an 8 from like a 1 and a 12. You can't get an 8. You can get a 13 or you can get an 11. And you can't get an 8 from a 3 and a 4. You can get a 7 or a 1. But I can get an 8 from the 2 and the 6. And if I need it to be a -8, then they would both be negative. So we'll have -2x and -6x. And this one, you can't just say like x times x. You actually don't know So it's going to be 3x times x, but what you don't know is, does the 3x go here or does the 3x go here? Like one of these is a 3x and one of them is an x. And the way we're going to figure that out is we're just going to do GCF factoring. So you have 3x squared and you have a negative 2x. What do they have in common? Well, they have a factor of x in common. And then once you've got that, you should be good. X times what gives me 3x squared would be 3x. X times what gives me negative 2x. That's negative 2. 3x times what gives me negative 6x. That would also be a negative 2. And then here's your check. Negative 2 times negative 2 is positive 4. And so all of them should check. Your factors would be 3x minus 2 and x minus 2. Next factoring problem, we're almost done, is 4x squared minus 9. Now this one you can do with an area model, but you probably don't, because we don't really want to multiply 4 times 9 to get 36, and we probably don't. Now what we need to remember for this is what is called the difference of squares. Have to begin to remember that. Difference of squares, because 4 is a perfect square, x squared is a perfect square, and 9 is a perfect square. Difference means subtraction. And so difference of squares always factors into conjugates. And so that will always factor into a plus b times a minus b. So one's a plus and one's a minus. And then you just take the square root of everything. The square root of 4 is 2. The square root of x squared is x. And the square root of 9 is 3. So that'll be 2x plus 3 times 2x minus 3. If you are like, I'm not sure, Miss Taylor, I think you're being dodgy, go ahead and you can set up your area model and multiply it. And 2x times 2x is 4x squared. 3 times 2x is 6x. 2x times negative 3 is negative 6x. And then you have negative 9. And what you'll notice is that negative 6x and 6x cancel out, leaving you with just the 4x squared and just the minus 9. So you can always do a check. That should not be copied onto formative. Okay, that's just a check. And our last problem. 2x squared minus 4x minus 30. And the first thing we want to do here is notice that there is a common factor. Here we have 2x squared, but if I look at this, 4 is 2 times 2, and 30 is 2 times 15. Now, typically we don't write that. I am writing it for the purpose of this to show oh, look, common factor. That can be factored out, leaving me with x squared minus 2x minus 15. And the reason we want to do that is because one, it's necessary to get it completely factored, but also it makes the rest of the factoring so much easier because the numbers are smaller. So now we'll set up our area model, and now we have x squared and we have a negative 15. And we look at the 15 and we say, all right, what multiplies to give me 15? Well, 1 times 15 and 3 times 5. Of those two pairs, which one can give me a 2? That would be the 3 and the 5. What do I need? I need a negative 2. If the 3 is positive and the 5 is negative, that would add up to give me a negative 2. Positive 3, 3 minus 5 is negative 2. And 3 times negative 5 is negative 15, which is what I wanted. So this is 3x, and this would be negative 5x. And this is one of the nice ones where you have the x squared, so you can just dump the x's out. This would be 3 and negative 5, and so my final factorization would be 2 times x minus 5 times x plus 3. And you need to get all of the factors out. So this video was maybe the longest of them. It was a 15-minute review of factoring to refresh your memory about that and go through that process and some of the concepts again.